Hello, I saw your question on the board, discussion board, and it's from 8.4. I guess it's number 7 out of the book. This section's on inverse variation. 8.3 was on direct variation, and this section's on inverse variation. The fan pulley and an alternator pulley are connected by a fan on an automobile engine. If the fan pulley is 105 centimeters in diameter and the alternator pulley is 75 centimeters in diameter, if the fan pulley turns at 330 revolutions per minute, RPMs, how many revolutions per minute does the faster alternator pulley turn? And so that's the question. You got to put the answer in here. So I tried to draw a picture. Here's the fan. Its diameter is 105 centimeters, and it's turning at 330 revolutions per minute. And we have this smaller diameter of 75 centimeters that's connected by our belt. And we're wondering how many RPMs is it running at. First thing, very important, you realize this is inverse variation. You know, as this pulley gets smaller, you know, the RPMs are going to increase. So as this quantity gets smaller, this one's on increase, and so that means it's inverse variation as opposed to direct variation. Okay, and so there's two ways the book shows to solve it. One way, this is one method. The second method, the first method's just using a proportion, and that would be okay. You may prefer that. So I wrote it as, you know, X, Y is an ordered pair. You have diameter and you have revolution per minute. And this is the equation for inverse variation. And with this given information, you can find K. So Y is the RPMs, which is 330. X is the diameter, which was given as 105. And then I just multiply these two numbers, and I find K is 34,650. So I put that back into the equation. So Y is 34,650 over X. And then X is diameter. We're given X here is 75. And so I use my calculator and I get to 462. So this is one way. You may prefer the second way they show you in the book using a proportion. It may be a little quicker, but I always preferred this method myself. Hope this helps.